A function over an interval is given by MVT. So in example number 1, the final average value was 4/5. The point at which that average value occurred was 25/4. And then yeah, this is the page that we went over yesterday, but like didn't go over. And then I'm actually going to go over all your homework from today that was due today too. But this was the one I couldn't find my answer packet to, and for whatever reason that board's frozen. You in the first quadrant. So in order to get your first quadrant, you had to find your roots as well as your y-intercepts and x-intercepts. So what we got is that we had 0, 0, and 3, 0. It was symmetric about the point x equals 1/2. So then at 1 and 2, it was at a height of 2. Not that that mattered so much, but they gave you the quadratic in quadrant 1, open, down. You found that area under the curve, and then you averaged it, and the average area under the curve was 3/2. And then down at the bottom, so these are simple, find the definite integrals. You have an upper and a lower bound, and then you have your function, and all you do is find its antiderivative using our reverse power rule. Plug in the upper and lower bounds, subtract the area between them, and get your final answer. Okay? And then we did 2 of the problems on the back. So let's go over the ones from the top. So here is D, E, and F. So for D you got 0, for E you got -2, and for F you got 0. And again, the reasons D and F are 0 is because those graphs are symmetric about the origin, because they are odd functions, and since the bounds to the left and the bound to the right are equal and they're odd functions, the area under their curves are 0 because the area above the curve and the area below the curve match, and we get 0. And then down at the bottom, I told you didn't have to do the very, very last one. And for the middle one, you should have gotten 2 pi. Because sine pi and sine 0 are 0, so they zeroed out. Okay, looking at FTC homework part 2 from Friday. Let's talk about that first graph. So for part A, you should have gotten 0 because a bound that begins and ends at the same bound is 0. For part 2, you went from 0 to 2, so that was a triangle and a rectangle added together. Or you could have done a trapezoid, and you got 3. For part 4, 0 to 4 was a trapezoid above and a triangle below. So you could have also changed it to be the integral from 2 to 4, taking our initial condition from part B and adding it to that integral in part C. And that is the fundamental theorem of calculus. It's saying if you have an initial, then you can use that to find your missing part. So initial, triangle above, triangle below, 3. And then in letter D and E, same idea, 0 to 6. You could take your initial, which is 3, and then change your integral to 4 to 6, and then use that to find the area under the curve. And then letter F. Yes. So yeah, did you ask why it's 2 pi in the numerator? Yeah. Because 2 squared is 4, and then 4 divided by 4 is 1. However, like, see, like, where can I point? Right here. Do you have it as, do you have your answer as just pi?
Yeah, I meant in like E, why I get it.
Sorry, right here. So this has a denominator of 2. So I created a common denominator. So when you multiply out your common denominator of 2 over 2, you got 14 over 2 plus 9 over 2, which got you to 23 over 2, and then 2 pi over 2.
Okay, so if we were to combine them?
No, you could have left it like kind of what I have boxed in purple. And you could have combined, like you could have just done 23 over 2 minus 2 pi. Is that what you had?
I had minus pi.
I mean minus pi, sorry. Yes. Sorry, I'm like answering you, but like taking care of a kid that's finishing their advanced algebra 1 test, kind of yelling at them that they need to be off now, and I'm multitasking. And then G and H. And then you can see I did I just like I did I the other day. So how I get my sketch is to plot everything from A through F. So I plotted all those points I got from A through F. And then I used the idea of the derivative and where it's 0 and where it's positive to help me get my concavities. I will gladly do that with you. So the idea is that you're given the initial condition of -2. So that's kind of like telling you that your integral is from -2 to x of f of x dx. And you're going to plug in from there. So for letter A, I kind of treated that as -2 to 0 of f of x dx equals f of 0 minus f of negative 2, where I was solving for f of 0, and I knew that f of negative 2 was 5. So it was like f of 0 minus 5. And then I had to find my integral from negative 2 to 0 using the graph, and the integral from negative 2 to 0 using my graph was a triangle with base 2 and height 2. So 1/2 base times height gave me 1/2 times 2 times 2, which is just 2. So then I had 2 equals f of 0 minus 5, added 5 to the other side, and got f of 0 equals 7. And then to find 2, I used my initial condition from that part A to find part B. So I could say, okay, my integral now starts at 0 and goes to 2 of f of x dx, and that's f of 2 minus f of 0, and I just previously said f of 0 was 7, and then I could find the triangle of f of 2 to 0, or you could have done negative 2 to 2, done your whole triangle, and used the initial condition they gave you. So you have a couple ways you can look at part B. So again, you could have gone negative 2 to 2 of f of x dx, but then that becomes f of 2 minus f of negative 2, and instead of plugging in 7, you plug in 5. That is the fundamental theorem of calculus part 2. And then you do something similar in part C. And again, I would probably, because part C is a circle under the x-axis from 2 to 6, I would make my bounds start at 2 and use the initial condition or the value I got in f of 2. So I would make my integral from 2 to 6 of f of x dx, and so that's equal to f of 6 minus f of 2, knowing that f of 2 was 9 from the step above. In 3a, my final answer was negative 3. In B, once again, I would have used the integral from 4 to 7 of f prime x dx, and said that that was equal to f of 7 minus f of 4. I'm picking 7 and 4 because 4 is the given, and it's also a 0 on that graph. So it's easier to pick up at 4 than it is at 0 from part A. And then that final answer was equal to 1. And then similarly with 9, you could go from 7 to 9. You can go from 4 to 9. You really have a lot of choices. And your final answer is 11/3. Okay? And then for sketching it, you would, like I said in the previous problems with like our other problems, take 0, negative 3, plot that point. Take 7, 1, plot that point. Take 9 and 11/3 and plot that point. And then since this is the graph of f prime, if you think about the derivative graph, if the derivative is positive, then my original is increasing. If my derivative is negative, then it's decreasing. And then if my derivative is at a 0, then I have an extrema. So that tells me that this goes from positive to negative. So on my graph of f at 4, I have an extrema, and it's at 5. So up, down, up. Sorry, I poked my paper. And then down here in example 4, all you had to do is set up the integral and use your calculator. Because again, anytime you have decimals, those are calculator problems. So your integral for 4 should have been the integral from 0 to 5 of the function 6e to the negative 0.1t dt. And then that would have been equal to r of 95, but we were told, r of 5, but we were told that r of 5 and r of 0 are given as 95 degrees at t equals 0. So that would be like r of 5 minus 95. Yes. You don't have it either?
Our next question is
7, 8, 9. I wonder if when I took a picture of my page, it just cut it off. Alright, no worries. Bumping to 7. Cool. Okay, jumping over to 7 then. Again, graphs are all over that AP exam. They're going to hit you with these small decimals on a non-calculator question. So the final answer in 7 of f of 4 is 9.2. And then in 8, it's 9 minus 9 pi over 2. And then in 9, you had to find part A, B, and C. So A was 14, B is 11, and C is 11 plus 9 5/4. Okay? Questions, comments, any of these you want to see the work for? Okay. And then the last page we worked on and turned in for today was that Big 10 and the worksheets 2 and 4. Hopefully worksheets 2 and 4 were really, really easy for you. Let's start with the Big 10. So the Big 10, you had to pay attention to what they were saying. So the answer to number 1 was 3/2. And then it said to cross off the value of the numerator of your answer. So you crossed off 3 from the 0 to 9. So the answer to 1 was 3/2, and that made you cross off 3. The answer to number 2 was -45/2. And then it said to cross off the sums of the numerator, so you crossed off 9. So 1 and 2 are just back to our basic antiderivative rules. And I like to mix all of them in because it's important for you to understand, okay, this doesn't have an initial condition, it's just an antiderivative. And then in part 3, you're finding g prime of 2. However, you're given the integral, so the integral is g of x. The derivative of the integral is that value, and then you plugged in your x, then you found g prime of 2. So the derivative of the integral gave you that function with x plugged in. Then to find g prime of 2, you simply plug 2 in for x and get your answer. Okay, 4 and 5. Not all of 5, but. So 4, your final answer was -2, because once again, took your antiderivatives using your power rules, plugged in your upper and lower, subtracted, and simplified. Okay, there's 5. Okay. 6 is a lot like the problem we struggled with before. If you have an absolute value, you've got to think about what the graph looks like and find the area under a curve. We don't have a reverse power rule or a formula that works for absolute value right now. You've got to break it into triangles. Seven and 8. So 7 is thankfully a fundamental theorem of calc part 1, because we don't have a square root rule yet for antiderivatives. So you couldn't actually take the integral and then find the derivative because we don't know a rule for a square root. So you had to treat that like exactly what it is, which is the fundamental theorem, which is to take the derivative of the integral, which means plugging in the upper bound. But since the upper bound was x squared, you have to multiply by the derivative of an upper bound, in this case 2x. Once you had your derivative, then you plugged in your 1. Okay, and 8 secant tan is the antiderivative of secant. So you take your antiderivative, you get your secant, you plug in your upper, your lower, and you simplify using our unit circle values. If you forgot what secants were, you could always do 1 over cosine. And then in 9, this is one of those questions where it's, do you understand integrals? Can I take an antiderivative of all of those, of none of those? So in this case, you can take the antiderivative of 5 because the denominator is always positive, therefore never 0, therefore integratable. In 6, however, though, because you take your antiderivative and you get negative 1 over x, you still can't find the value of 1 over x at 0. Therefore, it's undefined at one of its bounds and is unintegratable. And again, that's a technique you'll learn in Calc 2. So anybody moving further on in their calculus, this is a BC topic, which is Calc 2 in college. Once you found the one that was undefined, that's the number you crossed off. However, just talking about these, again, the denominator in 8 is always positive, as well as your restricted domain of your denominator in 7, given that it's the square root and squared. You can take it from 1/2 to negative 1/2. And then 10, talking about, again, integration and when it does or doesn't work and how to get a 0. If this is an odd function, that's like what I was hinting at with our homework earlier today, where we had the x cubed, the x to the 1/3. Anytime you have an odd function and it's symmetric about the origin, if you go from its opposite bounds, your answer will always be 0. Okay? And then in the last handout, we had worksheet 2, which I also have done. That one should have been like all of 2 seconds for you, because each of those were pretty much FTC in their most basic form. So again, for most of that, the answers were opposite each other because all they did was change the lower bounds of constants. So you had like 3, 2x, 2 minus 2x, sine x. This one was 18x. That was 2 sine x, cosine x. So there's a cosine x over on 10. And then down in 11, that was just f of x. And 12, you had g of x times g prime of x. Okay. So then what I did for worksheet 4 with the multiple choice was I actually put that on the Go formative. So I'm going to hit assign for you for that now. And then I just want to see. So again, you're on that go formative. Alright, let me just send you the link, like the direct link. Because it seems like you're the only one that has that issue.
I can't get into it ever. When did you guys set this?
This is every time.
I don't have multiple choice question 5 through 6.
What?
I don't have 5 through 7 on my worksheet.
Yeah, you have to do 5 through 7 now. That's what I said. I added 3 that weren't on your worksheet. I'm sending the link to you guys on Teams right now, the two of you. I can't get in. I don't remember the first day we did this, Brooke, honest. But I just sent you the link to go sign into it. And Carson, just try to sign in with something like a different way with the link I just sent you.
Well, Garrett Seaman and Nate Thomas, please report to the office. Garrett Seaman and Nate Thomas.
So number 1 or 23, whatever you want to call it. Great job. We went 13 for 13. Number 2, not so great. We went 6 for 13. So we were split between A, B, and C. And in that example, the reason that the answer is A is because, sorry, I have to actually get my handout out. Oh, there's my worksheet too. So in 82, it's talking about the rate of change. So you're doing the integral from 0 to 8. However, you had to plug in and find the values for your upper and lower bounds using the idea that it was not perfectly at those given points. And what you would do then is essentially find your derivative and find your zeros. Okay, number 3 or 91. What? Yeah. So it says the particle moves along the x-axis. Its acceleration is given if the velocity of the particle is 2 at t equals 1. Then the velocity of the particle at time t equals 2 is. This is FTC. So, what you had to do for that problem is set up your integral from 1 to 2 of a of t dt, and then say that that was equal to v of 2 minus v of 1, because the antiderivative of acceleration is velocity, upper minus lower. If the velocity of the particle is 2 at 1, v of 1 became 2. We were looking for v of 2. So you had v of 2 minus 2, and you used your graphing calculator to find this value here. So again, I told you they were calculators. So you take math 9, you do the integral from 1 to 2 of ln 1 plus 2 to the x dx. You get 1.346. Add 2 to that value, and you get E. That is the fundamental theorem of calculus. And then for 92, maybe better. You got D. Again, fundamental theorem of calculus. It said on what interval is G decreasing. So g of x is equal to the integral. So g prime would be the derivative of that. So what that meant was that g prime of x is equal to the derivative of that, or equal to sine of x squared. So to find when g is decreasing, you just needed to find when your derivative was negative. And again, you had a calculator. So you could just go to your graphic calculator, type in that function. You knew that it had to be between -1 and 3. So I changed my windows. Hit graph. And boom to boom. So you do second trace, 0. Find your value way over here. .772. Sorry, 1.772. And oh, that's right there. Okay. Then I threw on 3 questions you hadn't seen before that were also FTC AP questions. So in this question here, this was simply, a derivative of an antiderivative. Therefore, everywhere I had a t became an x. So that made your answer B. Or sorry, D. Everybody picked B. Okay, this one, same idea. The derivative of a constant is 0. So you plugged in your x, got the answer with which you had e to the 2x. So not C, but A. A little bit better. And 7, maybe I consider it a trick question, maybe not. What do you notice about both bounds in this case? They're numbers, they're constants, right? So if you took the integral of a upper minus a lower bound, we always get a number. The derivative of any number is, therefore, E is the correct answer.